All right, so here we go with our Chapter 7 study guide. And Chapter 7 was about the concept of a sampling distribution. Back when we learned this Chapter 7, if you're anything like the typical student that I teach in AP Stats, this is probably one of your lowest chapter test grades. It's a chapter that gives kids a lot of trouble, but it's mostly troublesome because at the time there's just so much new stuff that's coming your way. You had to learn all about conditions that go into the sampling distribution problems. You had to learn about setting up the formulas that go into making your normal CDF and all that. And there's just so many crazy pieces that go into it at once that it's really kind of overwhelming at first. Revisiting this chapter now, though, hopefully you guys will feel a lot better than you did when you first learned about it, because the things that you learned about in Chapter 7, we've practiced again and again and again in all those chapters 8, 9, 10 with the 4 steps. So hopefully the second time through, this isn't going to be so bad for you guys. In the little list of definitions and stuff that's going on right here, the last thing I have is just like a little bit of a note to you guys. If you're ever like, oh, I'm not sure what's going on with this problem, it's going to probably be some sort of normal CDF problem. It's going to end up being where if you're looking at a p-hat problem or an x-bar problem, where you're taking samples and building a sampling distribution, most of the time what they want you to do is a normal CDF to get your answer. It's just a matter of knowing the information that goes into it and being able to check your conditions and know your formulas. So this should not be all that bad for you. So let's go ahead and jump into our multiple choice questions. Starting off with number 1, we're taking a poll and we're going from 1,500 people to 4,000 people. And we want to know what that's going to do on our estimates. So the two enemies of sampling are variability and bias. Bias unfairly favoring one side, being too high or too low, and variability being like all over the place and not consistent. Bias cannot be fixed by increasing sample size. The only thing that really changes bias is your design. So you'd have to go back and collect new data. So all of the choices here that talk about changing bias aren't going to apply. What we're going to look at instead is the variability. And if you go from a sample of 1,500 to a sample of 4,000, that's a bigger sample. And I want you guys to think about the ice cream example I gave way back when in class. Say you have a big tub of ice cream and you take like a little taster spoon and get a sample of like a Rocky Road ice cream with like fudge and chocolate and vanilla and all this different stuff. This tiny little spoon compared to like this tiny little spoon could be very different from one another. There's going to be a lot of variability in the spoons because maybe this one's mostly chocolate and this one's mostly vanilla. But if I take a bigger scoop out of that ice cream, this scoop and this scoop are probably going to be somewhat similar. When you increase sample size, you decrease the variability between estimates because this sample is probably going to be similar to this sample right here. So the correct answer to this first question is choice A. It will reduce the variability of your estimates. So let's get on with our second question here. I like to put a very similar question to the second one on the Chapter 7 test. And it's usually one of the worst questions for kids because it's making you use the concept of a sampling distribution in a different context. It's not a p-hat and it's not an x-bar problem. So you can't just look at like a normal CDF. Okay? When you look at some other random thing, like this problem is talking about the minimum, you really just have to take lots of samples and see what happens. So you've got these 5 teachers, and you're going to pick samples of size 4, and you're going to calculate the sample minimum. So you're going to take 4 of those 5 dots, and you're going to figure out what the minimum is for them. So let's say I took these 4 dots. These were my 4 people randomly selected right there. If I did that, I would get for my sample minimum a 23. So my graph is going to have a dot at 23, and that's what several of these choices already have, so that's cool. And then let's say I got like the first 3 values, but then I got this 58 instead of the 42, so the 42 didn't count. Well, that minimum would still be a 23. So I'd have another dot at 23, and so on. I would do that for every combo possible. The only time my minimum will not be 23, let's say I picked these 4 as my random sample, where the 23 was not included. Well, now my minimum is going to be a 34. So the correct answer is going to be choice C. 4 of the 5 samples have a minimum of 23. But if I pick those ones that are circled right now, my minimum will instead be a 34. So C is my correct answer here. With sampling distribution problems, if it's a really, really small group, like this was 5 people, you can just do it yourself and it's not that bad. If your group gets a lot bigger, we usually use technology and simulations to get us a sampling distribution, because when the sample size is big, it's hard to make a good sampling distribution by hand. So our third problem here, moving on, is looking at the percent of people that own DVD recorders. This is probably an older question. The 46% of households own a DVD recorder, according to this problem. So that 46% is assumed to be the actual population value. So our real P is going to be a 0.46 in this problem. And what you would need to do, the sampling distribution of p hat is approximately normal as long as your conditions are satisfied. You'd have to do n times p, n times 1 minus p, and you got to make sure both of these quantities are greater than or equal to 10. That's the thing you would need to check here. It does work out, though. I'm not going to actually do this and check it in this problem, but those conditions are satisfied. So we would do a normal CDF to get our answer. But instead of showing it in like normal CDF format or asking for just a probability in the answer, they left it like they sometimes do in z-score formats. So first of all, they ask for the probability that at least half are going to be owning a DVD player. So my mean is the 46%. Half would be 0.5, that's going to be above it. And they want at least half, which is this area right here. So we want a probability that z is greater than, because it's a greater than probability, meaning that I can cross off that choice right there. And inside the formula, you're going to have your z-score setup. Z-score setup goes value minus mean up top. My value in the problem is the value that I care about, which is that we're trying to find the probability of, which is the half or the 0.5. So it needs to go 0.5 minus the mean of my sampling distribution is the real answer, which is 0.46. So I'm looking for a 0.5 minus a 0.46, meaning that this and this, and actually this, are wrong as well. The only thing left to us here is to figure out the bottom. So it's value minus mean divided by standard deviation. And the formula for that is your square root p1 minus p over n. I would use the 0.46 for my p, not the 0.5. So the correct answer on this guy is choice E. So on to our second page. This problem is a sample mean problem. And we are picking samples of size 16 from a population where they don't tell us what shape the original population is. We don't know if the original population is skewed or normal or something else. So the central limit says that if our sample size is at least 30, that means that the sampling distribution of x bar's graph is going to be approximately normal. So if your sample size is big enough, no matter what the population looks like, x bar will be normal. Unfortunately, our population is not big enough. We only have a sample size of 16. So we actually can't say confidently what shape the sampling distribution of the mean will be. We don't know. It's going to resemble whatever the population is. So if the population's left skewed, x bar would still be left skewed at this point, but we don't know what the population is. So we do not know that the distribution is normal. So the choices that talk about normal are going to be outs. The mean of your sampling distribution is the same as the mean of the population. So this graph would be centered at 45 for the mean. And for the standard deviation, this is a very common error, but you need to make sure you take the population standard deviation. So the standard deviation for x bar, you take your population guy, which is going to be the 15, but you have to remember to divide it by square root n. So you would do 15 divided by the square root of 30, getting you the answer of 3.75 for x bar's standard deviation. Kids always forget to use their little formula when they're figuring out the sampling distribution standard deviation. All right, on to this next problem here. I'm reading through this problem. It's talking about probability, kind of a tricky question, like, oh gosh, what's going on right now? Well, they're talking about a random sample, and they're talking about the sample mean. This is going to be a problem where if my sample size is big enough, I'm going to do a normal CDF. And it says that my sample size is 407. No, sorry, my sample size is 30. My population is 407. So my sample size is big enough that I can do a normal CDF. The mean for my population is a 71.27, it says. The standard deviation for X bar is not the 17.5. Kids use 17.5 a lot in this. They just grab the population number and they forget, like I said in the last problem, you have to divide that by the square root of n. So I would divide this by square root 30 to get my standard deviation. And on this problem, they actually wanted to know the 85th percentile. 85th percentile means the area that you see in orange right there is going to equal 0.85. Oops. So when you're doing a percentile problem, you know the area already. So if the area is 0.85 for the 85th percentile, I need to do an inverse normal on this problem because I know the area. If you set up inverse normal with a left area of 0.85, you're going to use the mean of 71.27. You're going to use the standard deviation of whatever this is divided out. You should get for your answer on this one choice B, which is 74.53. Final multiple choice question here. We've got an SRS of size 500 from a population that is this big, 37,000 at Purdue. And then you take an SRS of the same size from all the adults in the state of Indiana and you measure their heights. The standard deviation for Purdue and Indiana, so regular sigma, is assumed to be the same. The standard deviation is the same for your college and for your state. So if those two things are the same, for both of those problems, I would divide to get my X bars standard deviation, because they're asking about the standard deviation of the sampling distribution of mean. So they want to know what is the standard deviation of X bars graph. That's this formula right here. I would take whatever this number is, which is said to be the same for both, and the sample sizes are both 500. So I would divide by the square root of 500. I'm still going to get the same answer for this one and for this one. Okay, this goes back to my ice cream thing. I have the same size scooper for each problem, scooper of size 500. Doesn't matter if my ice cream tub is this big or my ice cream tub is this big, the scooper is probably going to look about the same no matter which tub I pull it from. The size of the scooper is a lot more important than the size of the tub. Population size doesn't do a lot for us in terms of changing variability as long as we're still under the 10% condition, which we totally are in both cases. So correct answer for this one is going to be choice A. Let's get into our free response question. And for this first free response question, it says in the problem that we're looking at tires, and these tires are whatever, we're looking at like how long it takes them to stop, I think it is. And it says in the problem that the distribution of the stop data is approximately normal. That is kind of uncommon in problems like this for the original population to be normal. But that's what it tells us. Stop distance is already normal before we worry about X bar at all. If the population is normal, it does not matter what my sample size is. My sample size could be very, very small. X bar will still look approximately normal. This first problem, though, isn't even talking about a sampling distribution. It just says, oh yeah, what's my 70th percentile of stopping distances? Nothing about taking an average or X bar or anything like that. Just what's the 70th percentile? Well, my original problem has a mean of 125 and a standard deviation of 6.5. And they want to know what the 75th percentile is. Sorry, I keep saying 75th. The 70th percentile. that's going to be a problem where you just do inverse normal. It's actually a lot like that multiple choice question we just did. You just do an inverse normal, mean 125, area is 0.7, and the standard deviation, you would use the original number. There's no dividing because there's no sample that we're taking right here. If you do that, the answer for this first one, if you do your inverse normal, which on your paper show your work for it, please, it's going to be 128.4. Please make sure when you write out your inverse normal that you label left area 0.7, mean 125. Write out what the commands mean when you do this, but that's the answer you should get. Second problem on this one is asking for the probability that in a sample of 5, so now we're actually taking a sample of multiple cars, at least 2 out of the 5 will have a stopping distance greater than the one we just got. Well, you sit there, they're asking for a probability, you're kind of like, oh gosh, I don't know what to do right here, this is confusing. But they specified the sample size of 5. Always ask yourself, if you ever hit a wall on a probability question, is it binomial? And it actually is. You either do take more than the last distance or you don't. 1 car independent from the next, 5 trials, and the probability of success for this one, they want to know that the stop distance will be greater than what we just found, greater than that 128.4. Well, the thing about it is that was the 70th percentile. 70% of cars have lower stop times than that 128.4. So 30%, the group above it, would be our probability for this. So this is binomial. I would do a binom on this problem, and you would want to write out in more detail when you do this yourself. They want at least 2. Well, if they want at least 2, that means what I would need to do, that means that they want 2, 3, 4, or 5. I could find those ones individually with a binom PDF. PDF is when it's just one exact one that you're looking for. Or I could subtract out the ones I don't want, which are 0 and 1. Those are the ones I want to get rid of because 2 through 5 are what I want. So when I do this, my trials is going to be 5. My, what else do I need to write? My probability is a 0.3. And then my x value is going to be 1 because CDF always does less than or equal to. We've been practicing binom quite a bit in these last couple chapters, so hopefully that is feeling pretty fresh. It comes up a lot on the AP test. And I would need to do a 1 minus on this because I want to get everything else but the 1 and the 0. If you actually do this, the answer for this one ends up being 0.4718. And for your problem, just write in context, like restate the problem. The probability that at least 2 cars in a randomly selected sample of 5 that stop greater stop distance, blah, 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 is 0.4718. So that takes us to our third question right here. What is the probability that a randomly selected sample of 5 cars will have a mean stopping distance of at least 130? So we're looking at a sample of 5 cars, and we're looking at what the mean stopping distance is going to be. This is a normal CDF problem with a mean of whatever the population was. Population was 125. And this is X bars graph now that we're looking at. We're looking at the details on a sampling distribution. For X bars graph, we don't use the 6.5 from earlier. Instead, you would need to make sure that you took your 6.5 and you divided it by the square root of your sample size. My sample size is 5 for this problem. Now, with a sample size of 5, we would actually be in trouble. We would not be able to do normal CDF if it didn't say the population was normal. Because the population is normal, we are allowed to figure out that X bars graph is normal regardless of sample size. So for this problem, we would be able to do our normal CDF. They ask about at least 130. So I'd have a 130 over here. After I get that 130, it's going to be everything greater that they're looking for. That's what they ask about in the problem. At least 130 feet. You just do your normal CDF from there. And if you do that, you should get 0.0427. So that is going to be my probability on this one. Let's get to this last problem. I don't want to go over this. This is the one you guys try yourself, but I want to make a comment on this first part right here. When it says to describe the sampling distribution for this, they're talking about socks. Outliers aren't going to be relevant right here. So for socks, you have shape, you have center, you have spread. The shape is going to be approximately normal, assuming conditions are met. Don't worry about O. For center, give the mean of the sampling distribution, same as the mean of the population. And when you do your spread, you should be reporting the standard deviation of the sampling distribution. So it's not just the number from the problem. You have to make sure you divide it by the square root of your sample size. So that is the key stuff you guys need to remember from chapter 7.